Okay, picture this. You're hearing these terms everywhere, right? AI agent, agentic AI.
In meetings, articles.
Yeah, exactly. And honestly, they sound, well, pretty much the same. It's easy to just lump them together.
Very easy. Like maybe it's just the next buzzword,
Yeah.
one replaces the other.
Right. But what if there's actually a critical difference? Something that really changes how we think about AI getting stuff done in the real world.
Oh, there absolutely is. And yeah, that confusion is super common, but it's not just semantics, not at all.
Okay.
Thinking they're the same is kind of like looking at, say, a star quarterback and saying, yep, that player is the whole team strategy, the coach's game plan, everything. The player's amazing, essential even, but the coordinated system, the whole team working together, that's different.
That's a great analogy. The player versus the whole orchestrated play.
Precisely.
And that's exactly the puzzle we want to tackle today. We're doing a deep dive into that very confusion, AI agents versus agentic AI.
Yeah, we've been digging through a whole stack of sources for this one. Industry reports, company stuff, even SEC filings. NVIDIA, IBM, Google Cloud, Microsoft, Salesforce, you name it.
Right. And our mission here is really to pull out the key insights from all that material.
Yeah.
We want to, cut through the noise a bit.
Help you see the nuance clearly and really understand why this distinction matters for figuring out AI's potential in your work, your industry, wherever you're seeing AI pop up.
So yeah, if you felt a bit overwhelmed by the jargon, or maybe you're just curious how AI is moving beyond simple tasks to tackle really complex stuff, this deep dive is definitely for you. Okay, let's get into it.
Let's start with the basics, the building blocks. What exactly is an AI agent?
Good starting point.
According to the sources, you should think of it as basically an autonomous piece of software designed for a very specific job.
Like a digital specialist.
Exactly. It senses its environment, uses AI, often an LLM, to figure out what's going on, and then takes actions to hit a specific defined goal.
And I saw that core loop mentioned again and again in the sources.
Yes.
Perceive, decide, act.
Yes, that's fundamental. It perceives input, maybe a user query, data coming in, an alert.
Okay.
It decides what to do based on its programming or AI logic and its goal,
right.
And then it acts, sends that email, gives an answer, updates something, triggers another process. That's the core engine.
Makes sense.
Yeah.
And these agents, they have some key characteristics, right? They're powerful, but in a specific way.
Definitely. First off, they're very task-specific, built for a narrow, defined job, like filtering emails or handling basic IT questions.
So not generalists.
Not at all. They have limited autonomy. They operate within pretty strict rules or parameters. Often reactive, they wait for something to happen. Their decision logic is local. They only care about their little world, their specific task. They don't really know or care about the bigger picture outside that task.
And memory. This seemed like a big deal, especially since the underlying LLMs can be forgetful.
Hugely important because, yeah, LLMs alone are often stateless. They forget the last turn of the conversation. Agents add memory on top.
What kind of memory are we talking about?
Well, the sources broke it down. Short-term memory, like remembering the context of the current chat or task. But sometimes longer-term stuff, too. Episodic memory, remembering past interactions. Semantic memory, recalling facts relevant to its job. And even procedural memory, remembering how to do things, how to use its tools.
Okay, so memory makes them much more useful than just a raw LLM for a specific job.
Absolutely. Gives them context and consistency within their domain.
And the other key piece seem to be tools. The LLM is the brain, but tools are the hands.
Perfect way to put it. Tool integration, connecting to APIs, databases, other software. That's critical. It's how agents actually do things in the real world beyond just talking.
Right. An agent without tools is just generating text.
Exactly. An agent with tools can reset your password, book a meeting, analyze data in a spreadsheet.
Okay, so the analogy holds. An AI agent is like that specialized expert, really good at one thing, needs clear boundaries.
Precisely.
And we saw some really cool real-world examples in the reports. Like in IT support, that seems like a prime area.
Oh, yeah. IT departments get buried in repetitive stuff. Password resets, basic troubleshooting.
Tell me about it.
So one report highlighted Equinix. They deployed AI agents, specifically one called eBot.
eBot, okay.
And it acts as that first line of defense. It monitors, logs, incoming tickets, that's the perceive.
Wow.
It triages the issues, figures out what's urgent, who needs to see it, that's the decide.
Right.
And it might trigger automated fixes or route the ticket to the right human, that's the act.
And the results?
Pretty staggering, actually. The source mentioned 96% routing accuracy. And get this, average triage time dropped from 5 hours to 30 seconds. Millions in savings reported, too.
That's a textbook example of an agent nailing a specific high-volume task.
Exactly. And there was another one, Wiley, the publisher, dealing with customer service spikes.
Always a challenge.
They brought in a contact triage agent. It helps handle the volume, drafts responses for humans to approve, sometimes resolves simple stuff itself, and spots trends.
And the impact?
A reported 40% increase in improved case resolutions. Fast, efficient, focused on that one area.
It's not just back office either, right? Sales came up too. Connect Team.
Yeah, Connect Team used an AI agent they called Julian for initial sales outreach, like making those first phone calls.
An AI making cold calls.
Basically. And Julian was apparently very busy, handled over 120,000 calls autonomously per month.
Whoa.
Reduced meeting no-shows by 73% by handling confirmations, doubled their call coverage. The sources said it saved them over $450,000 a year in SDR salaries.
Incredible ROI. But again, focused on that specific sales function.
Right. Still a defined task, even if high volume. And there were other quick hits, too. JP Morgan using agents for contract review.
Seconds versus hours, I think I saw that.
Yeah, identifying key clauses based on rules. Amazon Sequoia for optimizing inventory and getting orders out 25% faster. Agents drafting emails, scheduling, expense claims. Lots of specific, valuable tasks being automated by these agents.
Okay, so that paints a really clear picture of AI agents. Specialized, task-focused, perceive, decide, act. But now, the plot thickens.
Right. This is where it gets really interesting and where that confusion creeps in.
Yeah.
The leap from AI agents to agentic AI.
And crucially, it's not just having lots of AI agents, right?
Absolutely not. That's the key mistake people make. Agentic AI isn't a collection of independent workers. It's a system-level paradigm. Think of it as an overarching framework that actively orchestrates multiple agents or specialized AI modules.
Orchestrates. Okay.
Yeah, coordinating their actions dynamically to achieve complex, high-level goals, often with minimal human intervention day to day. It's about the whole system having agency.
Ah, okay. So back to your analogy. If the AI agent is the star player,
Agentic AI is the coach, the general manager, the playbook, the real-time communication system, the adaptive strategy, all coordinating the players towards winning the championship, not just one play.
got it. So what defines these agentic AI systems? Much higher autonomy, presumably.
Very high autonomy, yes. They operate proactively across entire workflows, and often these workflows cross different departments or data silos. Think supply chain, talking to logistics, talking to finance, automatically.
Wow.
They can initiate actions based on the overall goal without waiting for step-by-step instructions.
And the goals are different too. Not just reset password, but something bigger.
Definitely. Their goals are end-to-end and strategic, optimizing the entire global supply chain for resilience or accelerating the discovery of a new drug, complex multi-step objectives, and they can adjust sub-goals on the fly if conditions change.
How do they manage that coordination architecturally? How does it work?
They're inherently modular and orchestrated. It's like a system of systems.
Right.
Typically, there's a central orchestrator, could be a powerful LLM, could be a specialized AI that does the high-level planning.
Okay.
It breaks the big goal down into tasks, figures out which specialized sub-agent or module is best for each task, assigns the work, monitors progress, and makes sure they all work together smoothly.
So the planning and reasoning must be way beyond what a single agent does.
Oh, much more sophisticated. Agentic AI can plan many steps ahead across different domains and agents, and crucially, adapt the plan dynamically based on new information or unexpected events. The sources mention things like iterative perceive, reason, act, learn cycles.
And reflection loops.
Yeah, where the system literally evaluates its own performance against the goal and adjusts its strategy for next time. It learns from doing.
And memory must be even more critical here, across long, complex tasks.
Absolutely. We're talking robust, long-term memory, knowledge stores that retain context across workflows that might span days or weeks. They learn continuously, building what one source called a data flywheel.
A data flywheel. Unpack that a bit. What does that mean here?
Good question. It means the results of the system's actions. How well a particular shipment routing worked, how accurate a demand forecast turned out to be, that data gets fed back into the system.
Feedback.
Exactly. It feeds back into the models, the planning logic, the knowledge base. So the system learns from its own successes and failures in the real world, constantly getting better at strategizing and executing over time. It's a cycle. Act, generate data, learn, act better.
That's a massive step up from a pre-programmed agent.
Yeah.
So where do humans fit in with agentic AI? Minimal oversight.
Generally minimal in the day-to-day tactical stuff,
Yeah.
yes. Humans are more involved in setting the high-level strategic goals, defining the rules of engagement, the ethical boundaries, the critical guardrails, like get human approval before spending over $1 million. And reviewing overall performance, handling major exceptions the system flags. It's strategic direction and oversight, not micromanagement.
So the analogy here, conductor of the orchestra, the general coordinating the battle plan.
Both work well. Or that digital twin idea from the supply chain reports a dynamic, autonomous system managing a complex real-world operation in real time.
Okay, this sounds potentially game-changing. Let's get into those transformative stories the sources highlighted.
Yeah, this is where you really see the power. There was a great case study of a multinational retailer. They were plagued by stockouts, delays, the usual supply chain nightmares from having everything fragmented.
Been there.
So they didn't just add point solutions, they implemented an agentic AI platform. This thing had a master planner AI coordinating specialized sub-agents.
Look.
Demand forecasting agents, supplier risk monitoring agents, inventory management agents, logistics routing agents, the whole 9 yards.
And this platform didn't just report problems, it fixed them.
That was the amazing part. The sources said it would autonomously detect a demand surge in one region or a delay from a key supplier.
Correct.
And the orchestrator would instantly tell the logistics agents to reroute shipments, tell inventory agents to shift stock, maybe even nudge production planning all automatically in real time without waiting for humans to have meetings.
Wow. Coordinating across all those silos automatically.
Exactly. What used to be slow, manual, cross-departmental firefighting became this continuous self-optimizing flow.
And the results, the sources mentioned simulations, right?
Yeah, in simulations, they saw a potential 20% reduction in stockouts, 15% better delivery reliability. That's optimizing the entire system, not just one task. Huge potential impact.
Truly transformative. What about R&D? That discovery example was fascinating.
Oh, yeah. Microsoft's discovery platform. Finding new materials or drugs usually takes ages, right? Months, years of lab work.
For sure.
With this platform, using Agentic AI, researchers set a high-level goal like find a new battery material with these properties.
The AI takes over the grunt work.
Not just grunt work, the complex iteration. Behind the scenes, an agentic framework coordinates multiple specialized agents. One scours research papers, another designs and runs simulations, a third interprets the data.
And an orchestrator puts it all together.
Right. A meta agent analyzes the results, refines the hypothesis, plans the next round of simulations, iterating incredibly fast, the outcome reported. Finding a novel material prototype in around 200 hours.
200 hours versus potentially years. That's unbelievable. It shows how agentic AI can tackle these really complex, knowledge-intensive, iterative problems.
Exactly. And there were other examples too. Flexport, using agentic systems for global freight forwarding, reported 30% cost cuts, 25% faster transit. DHL's route optimization that learns over time. Financial services using it for complex real-time fraud detection or end-to-end loan processing. Manufacturing optimizing whole production lines. These aren't just task automation, they're optimizing entire functions.
Okay, so putting it all side by side, let's really nail down the difference, because understanding this feels crucial. It's more than just a name.
Absolutely. Let's recap the core differences based on the sources. AI agents. Limited autonomy, task-specific goals, often a single module, local logic, maybe short-term memory, limited planning, higher human involvement needed for workflow, lower risk generally.
Right. And agentic AI.
Agentic AI. Very high autonomy, strategic end-to-end goals, orchestrated system of multiple agents, integrated planning across domains, often long-term memory and continuous learning, advanced adaptive planning, minimal daily human oversight, more strategic, higher risk profile due to complexity and autonomy.
That distinction highlights what the sources called the orchestration premium, doesn't it?
Exactly. The value isn't just summing up what each agent does, it's the emergent intelligence from them working together, coordinating dynamically, adapting as a system. That solves problems that single agents or even just a loose collection of them simply couldn't handle.
The whole is truly greater than the sum of its parts.
Right.
But
There's a catch.
right, the complexity value trade-off.
Absolutely. Agentic AI offers massive potential, but let's be real, it's significantly more complex to build, integrate, and manage.
Why so complex?
Well, you're building a whole system, not just one piece. You need to manage how all these agents interact, share data reliably across maybe different company systems, build that sophisticated orchestrator, handle the communication. It's a much bigger investment upfront and ongoing compared to deploying a single focus agent.
And that is exactly why you need to know the difference.
Yeah.
It's not academic. It directly impacts your AI strategy.
Totally. It affects where you start, how you allocate your budget and people, what kind of results you expect and when, and critically, how you manage risk.
If you're thinking about where AI takes you next, beyond the low-hanging fruit, this distinction is step one. Get it wrong.
And you could waste a lot of resources trying to solve a system problem with task agents, or massively over-engineering a simple task with a complex agentic framework leads to frustration and failure.
Which brings us to the practical side. Implementation and risk. The sources had clear advice here. When do you use which?
Use Agentic AI for those big, complex, multi-stage workflows needing continuous adaptation and coordination across functions. Think supply chain optimization, R&D acceleration, complex financial modeling.
Okay. And stick with simpler AI agents for
targeted, well-defined tasks, automating specific processes efficiently, IT support, email drafting, data entry, simple Q&A, specific monitoring tasks, faster to deploy, clearer scope, lower risk for point problems.
and governance. The sources were really emphatic about this, especially for agentic AI.
Non-negotiable. Because of that high autonomy and complexity, the risk profile is higher. You absolutely need robust governance frameworks.
Like what specifically?
Clear audit trails, knowing why the system did what it did. Strong security, the sources mentioned. Real risks like memory poisoning or agents gaining unauthorized access. And built-in guardrails.
Guardrails like human approval steps.
Exactly. Human checks for high-value actions, things impacting safety or compliance, things this system flags as uncertain. These aren't afterthoughts. They have to be designed in from the start. You can't just let a highly autonomous system run wild with the company credit card, right?
Right. You need the safety net.
Precisely. And that ties into the human in the loop, or HITL. It's not about babysitting the AI. It's about collaboration and trust.
So HITL is still key, even with high autonomy.
Yes, especially for building trust and managing risk. Humans provide oversight at key points, handle the weird edge cases that AI hasn't seen, give feedback for learning, and set the overall strategy and ethical lines. It's augmentation, not replacement.
Makes sense. Okay, let's wrap this deep dive up. Quick summary.
AI agents. Smart, focused building blocks, great for specific tasks. Perceive, decide, act in a narrow scope.
Got it. Component level. And agentic AI.
That's the powerful orchestrated system, coordinates multiple agents for complex, dynamic, strategic goals, high autonomy, continuous learning, the framework.
Component versus framework. Player versus team strategy. Got it. And the future looks agentic.
That's what the sources project. Dramatic growth in agentic AI adoption. It promises huge leaps in efficiency, adaptability, tackling problems we couldn't automate before.
It really feels like a major shift.
It is, towards AI systems that are more proactive, strategic partners, capable of managing themselves towards goals.
Which leaves us with a final thought to chew on. As these agentic systems get better and better at planning, at reflecting on their own actions, at self-improvement, basically becoming self-evolving to some degree, what does the future of work really look like then? How do we collaborate effectively with systems that can manage and optimize entire business functions autonomously? What's the next frontier when AI doesn't just do tasks, but can manage itself and other AIs towards achieving strategic objectives?
Yeah, that definitely raises some profound questions about our roles, the skills we'll need, and what true human-AI collaboration will mean down the road.
Something to really mull over. Okay, thanks for diving deep with us today on this fascinating distinction. Keep exploring, keep learning, and keep asking those critical questions.